In this video, I will continue talking my example, which I did it in the previous presentation. And as I told you here, we will continue working on the systematic sampling by making the intervals, which is here in the selected invoices 80, and the intervals here for the bill of lading is 70. And now let us work on the interval for the customers. So here I have 30 pages, in each page 50 lines. So first we multiply 30 times 50, we get a population of 1,500 lines. And based on that, I will create the interval. So 1,500 divided by 75, the interval will be 20. So how can I make it here? We will start page 1, line 11. And then we will start adding up for everyone. For every item, I will add up 20 lines. So the next one is going to be page 1, but the lines will be 31. And the next item should be 151 because I keep adding 20. But since we have 50 lines in each page, is going to be here page 2, line 1. And then we add 20, page 2, line 21. Then page 2, line 41. Then page 3, line 11. And we keep adding 20 lines. So this way we call it systematic sampling. So with this in mind, we learned how to do the systematic and the random sampling. And now let us move to the next item, which is the sampling risk. As I mentioned in the previous video, we don't recommend either big sample or a small sample, because if we have big sample or a small sample, we will have some problems that might arise. So here the auditor has to assess the control risk before he starts. And for example, if the auditor assesses the control risk very high, it means the auditor will select a big sample because he doesn't trust the control of the company, and this will affect his efficiency. If he assesses the control risk is too low, it means the internal control is effective, then the auditor will choose a small sample, and this will affect his effectiveness or his opinion. And this is what has been mentioned in Connect. When you study GLIME, GLIME is developing the same table as Connect, but in a different way. So GLIME says if the control is less effective, which means the control risk is very high, and this will affect the auditor's efficiency. And the other side, if the control risk is very low or the control here is very effective, it will affect his opinion. But also GLIME is going another step further, which is the sample here. If the sample indicates a material misstatement exists when it doesn't, this will affect the auditor's efficiency because the auditor has to spend more time. If the sample indicates a material misstatement doesn't exist, but in fact it does, so this will affect the auditor opinion. So please keep this in mind. So in the previous video and so far, I was trying to show you how to use different methods to select the items in each sample, whether you use random sample or statistical sample. Now, the next point is how about the size of the sample? We select the sample size either under statistical method or non-statistical method by using an equation. So if we use a statistical sample, we calculate the sample size by getting the population size times the incorrect acceptance coefficient plus incorrect rejection coefficient times standard deviation divided by tolerable misstatement. And of course, the whole equation will be to the power of 2. In every example, when I ask about the sample size, I will give you the acceptance coefficient and the rejection coefficient. But your job is to calculate the sample size based on the table we have it here. So let us look at this exercise. Here we have an auditor needs to estimate the total value of the invoices. The estimated standard deviation of the population is $30. And now the tolerable misstatement 45,500. The risk of incorrect rejection 4.6 and the incorrect acceptance 5. So based on the 5% of incorrect acceptance, we get 1.64, the incorrect rejection 2, and then we make the sample size. As I said, we need to get the population size here times the incorrect acceptance plus incorrect rejection coefficients times the standard deviation. So here, the sample size is, the population is 5,000, and the 5,000 is here. It's just hidden behind the camera. So 5,000 is the population size times the incorrect acceptance 1.64 plus incorrect rejection 2 times 30 divided by 45,500 to the power of 2. We get 144 accounts. So this can tell you the sample size from 5,000 record is only 145 accounts. Now, how about another example? We need to get the sample size here. So feel free to stop my video and take a minute to read the example. And let us go through the same steps of calculating the sample size. First, as I say, we need to get the incorrect acceptance and incorrect rejection factor. And then we get the population, which is 10,000 times incorrect acceptance plus incorrect rejection times standard deviation over tolerable misstatement. We get 183. So in both examples here, I was showing you how to do the sample size based on a statistical sample. The next point is, assume the following result. What about if the book item is 149 and the audited value of the item is 146, the standard deviation 28. We made the calculation here, and now we get the sample size, and we need to get the point estimate of the account audited value. We get the number of the accounts from the sample, which is 146, times the accounts 10,000, we get 1,460,000. And then how about the projected misstatement of the population? We get the book value of the population, which is 1,500,000 minus 1,460,000. We get the difference here, which is the projected misstatement, 40,000. And how about the adjusted allowance for the sample? We get the misstatement, which is 60, times the population size, times incorrect account coefficient, incorrect acceptance coefficient, times the sample standard deviation over the square root of the sample size. We get the allowance of sample risk. And finally, based on that, we say whether we accept it or reject it. So we get the projected misstatement plus or minus the allowance. We get here the amount range between 6,494 and 73. Since the amount is falling within this one, then we will reject it. If it's less, then we will accept it. The next one is how to do the sample size based on non-statistical sample. I take the same equation we have it for a statistical method, but then we start to change the terminology. So here, instead of population size, we call it population value. And instead of the incorrect acceptance and rejection, we get the reliability factor, which will be given to you in the exam. And then we do it this way. So we get the population value times the reliability factor divided by tolerable misstatement, and this will give us the sample size based on non-statistical method. And here is an example. Feel free to stop the video for a minute, read the example, and now let us work on the equation. So here is the equation. We get the maximum level, which is 3. And here also the maximum is 3. So we multiply the population value, which is 330,000 times 3, this one the maximum, divided by tolerable misstatement. So the sample size will be 33. Another example. And here also take a minute to read the example, and then let us work out the example, which is the population value. First, we need to check it here, the level of the risk. The previous example, it was maximum. Here we have moderate. And then we get the population value, 1 million times 1.6, which is the reliability factor, divided by tolerable misstatement. We get the sample size, 32. So this is in brief the methods for creating sampling and non-sampling way, how to do the method like random or statistical sample, how to do the sample size based on a statistical and non-statistical method. I hope you find those 2 videos useful. And if you need any more explanation, please let me know. Thank you so much. Bye-bye.